Hey everyone. So this is a calculator-like project that I'm currently working on, and it's not merely a calculator, it's supposed to be more than that. So let me just give you a quick demo of this before I start talking about how this is working behind the scenes and how this is not actually a simple uh, eval function where you just give in all the mathematical stuff as the input and it spits out a value as output. This actually uses a lot of stuff from the crafting interpreters book, which is used to make interpreters, tree walk interpreters specifically. So let me just give you a quick demo first, then we can talk about how this is working behind the scenes. So first of all, it can do all the basic mathematical stuff, which is like to, wait, I made a mistake. Let me just run it first. Now, hmm, let me make this a little bit complex. Wait. So yeah, the actual answer is right here, -9. And this all the extra stuff is actually for the debug purpose. It's not supposed to be here when it's actually running. So this is how it's working behind the scenes, but let's not talk about that currently. uh, let's see how this is working behind the scenes later. First of all, it's actually doing all the evaluation stuff here, and there is another extra feature that I have currently working on, which you can see in the latest git log. It's actually the answer variable. So if I do a and s, and it just gives -9, which is actually currently stored. So it can store certain stuff as a variable inside it. There's that, and then I have also implemented constants like pi, g, and all the other stuff like Avogadro's number. So there's actually a list of it that I have put it here. Let me show you. So yeah, these are all the constants that this currently supports. So I am currently working on implementing functional features. Like, it's not actually there, but what I'm trying to implement here is something like uh, log224. So something like this, where it a function takes some inputs, one, two, or maybe not even one, like for help functions, which will give answers like what will be there in the program. So functions like this. So that's what I'm currently working on, and it's not implemented yet. So this is saying syntax error. So this is what it's currently at its core. So let me just hide the terminal here, and let me show a preview of what the readme file is so that you can get a clear idea here. So basically it's a work in progress. It's a domain specific language kind of stuff, not actually just a calculator. I will later be implementing stuff like conversions, encoding and decoding, conversions like hexadecimal to octals and others. It's supposed to be a quick and handy tool to do all these kind of things in just one go. And you just give an input string like this, and it spits out the output. Currently it can support the answer variable and the things I just showed you. So the actual way this is implemented is right here. First of all, there is the scanner part where it actually scans all the things, and then, so as I was saying, it actually scans all the given text here. So I gave it to asterisk to -9 minus. So it actually stores all these in a token form, and this is actually being done by the scanner.cpp file. So it's actually converting all this into a token where I can give it multiple things, like, and it converts it into a token. So token code is basically the enum I'm using here. Let me show you here what's happening. So this is basically the tokenizer, which actually see, if it sees plus, then it gives a token plus, and so on and so forth. So this actually tokenizes the whole input string into a token, into a list of tokens, which is stored in a vector. right here, and it's then being output. So that's that. And after that, we build an abstract syntax tree using the parser. uh, the thing is that all of this can be done in a one step process in a simpler way, but I was trying to learn how to make programming languages, so I thought that this, although it might become a larger program, but I could be able to learn a lot of stuff. So that's why I try to implement it in three steps. The first part obviously was the scanner, where it tokenizes all the numbers and maybe later strings, where it could be hexadecimal or like basic base 64 encoding, decoding, and ROT 13 algorithms, Caesar ciphers and stuff. So it was meant to be also do those stuff. So that is handled by the scanner slash tokenizer, which actually recognizes numbers, operators, parentheses, and stores the alphanumeric stuff. So after that, the abstract syntax tree, which is actually the parser. Uh, yeah, this file actually makes parses it into a kind of hierarchy in a tree format, right? So I can't actually show you it like in a tree, but you can get the idea of how it's working behind the scenes and producing these in a bracket. So this is like the BOD mass rule, which we were taught in high school. So basically it's converting the precedence of like which operator should be given priority first. Like we can see asterisk is given more priority, and parenthesis when given is given even more priority than any of these. So then there is exponent, which is given more priority than multiplication. So all these features are converted into a tree using the parser file, which is this one. So basically it starts with this parser.parse function and goes on term, then calculating factors, and then exponent and unary. So it's looks actually pretty complex, and it took me also a lot of while to actually understand how all of this thing is working. But I think now I can say I can finally get somewhat 90% of the whole concept of how this is working. And earlier I had implemented the logs programming language, which the book teaches to build in Python. So I have quite a good idea of how this is working. And after re-implementing that similar feature in this one in C++, I think I got a better idea of how this thing is working. So I have added a few help things. This is not actually supposed to be in the output, but this is for me for my debugging purposes. So there is this part, and after that we have the actual, wait, so this is the AST printer. This is actually a helper. So this actually helps me see how this is being made in a syntax tree in the program, so that if there is an error in the operator precedence, I could figure it out. Because there was earlier an error where the plus minus were given more priority than multiplications, and I saw that the strings were reversed, the tokenizing. So I actually switched that, so that actually helped catch the error. So this is the actually helper. It doesn't actually help in the actual program, it's just for my debugging purpose. And the actual one where the processing begins calculations, it's inside this file evaluator. And this is the actual file where all the mathematical stuff is actually implemented. So basically for plus minus multiplication we can see this, and for division by zero we are throwing an evaluation error, and unary statement is for like -5 groupings and all these. So if you have read the book Crafting Interpreters, then you would be very much familiar with what all of these functions are supposed to be doing and the visitor pattern here. So I can't actually totally explain you this in one go. Actually for it's just supposed to be as a showcase for what I'm currently doing. So this actually is the last step, where it calculates all of the expressions, and the main file which is handling all this scanning and parsing and then the evaluating part is actually right here. So this one is actually getting the inputs from the command line first, and then is running, giving the string first. So first of all, we give the scanner the source, then scanner converts into tokens and returns the vector of tokens. And after that, we get the parser to convert all of that in a syntax abstract syntax tree. And we are also giving a env so that we could store that answer variable, and which keeps changing. So we are having an environment here for the evaluator. And if we get a parse error, then we throw a syntax tree and return back so that it does not crash the whole program. After that, we are printing the expr. This is actually supposed to be commented. It's just for the debugging purpose. And later on, we are doing the actual evaluation here. So this is using the std variant of C++ feature, std variant feature of C++, which can store multiple data types at one time. This is like unions in C. So we are basically getting the answer from the evaluator right here, and then we are storing the answer into the answer environment variable and also outputting the answer right here. And if there is an evaluation error, we just throw it. And this one is used to show all the tokens here, which is not actually needed. So this is for today. I think I'm done explaining. So basically, this is a side project that I was currently working on. It's been actually 4 days that I'm currently working on it, and I think in 2 or 3 more days, or actually up until Sunday, I next Sunday, I think I can finish this by adding the functional features which actually I want to implement. That's the actual core feature of this thing, which I actually wanted to implement. And once I get that part done, then I will add some extra syntactic sugar type stuff, where uh, I can't actually think of how it will be implemented, but basically this is the code that I am building. Once the core is done, then I will make extra syntax which will be more like a better way to give input, and not just call braces all the time, because typing braces from the keyboard actually takes time. So that would be a later project that I will do. But currently, I think first of all, the main target here is to implement function calls like logarithm, sine, cos, tan, and all those stuff. So let me know how you feel about this project, and please comment down in the comment section if you have anything to say. So I think that's all for today, and bye to everyone.